Okay, so welcome to the second lecture in Module 2 about machine learning models. So in this lecture, we are going to look at decision trees and random forests. So let's start with a short recap of fundamentals of tree-based machine learning models. So scikit-learn uses the classification and regression tree, so in short, CART algorithm to train decision trees. So CART always creates a binary tree, as you can see here, meaning each internal node has two child nodes. So the basic idea behind this algorithm is to split the data to get best possible grouping of data based on some features. So how does this algorithm work? Okay, to learn about this, we will use this simple golf playing decision data set. So in this data set, we would like to predict if we would play golf or not, given a set of features such as weather condition, temperature, and so on. So how does this algorithm work? So step one in this algorithm is that we start at the root node with all training instances. So step two is to split the training data into two subsets using the feature that produces the purest subset. So how? Let's look at an example for classification using this data set. So before we can start to train a machine learning model, we'll use label encoder to convert all values to numbers, as you have experienced from these notebooks. So to split the training set into two subsets, we use Gini impurity measure, which tells us what is the probability of misclassifying an observation. So PIK is the ratio of K instances among training instances in the node we want to do the split. So this equation is not complete yet. So the equation in the previous slide will give us the Gini impurity for subsplit, but we would like to know the Gini impurity measure for the entire split because the data will be split into left and right. Therefore, we will need to weigh them accordingly. So the cost function that the algorithm tries to minimize is this. So we will look further into this in a couple of slides, how to calculate this. So our train model split the training data based on the outlook in the root node. So let's look at how it did this decision. So here we have the each of the values in the outlook feature. So overcast, rainy, and sunny. And here are the values for them, 0, 1, and 2. So we start with calculating for overcast. So we have 4 instances of overcast of 14 days. So in all these 4 cases, there are yes. So then the rest are no. So that's it. And so this would be the left split, and the right split would be the rest of the days, 10 of the 14 days. So in those cases, 5 days is yes, and 5 days are no. And here is the Gini impurity measured. And we have to do the same for the rainy days and sunny. As you can see here, we have 5 days where it's rainy. So 2 of those days it's possible to play, and 3 days no. And the same here. So from the outlook feature, the best choice is overcast as it minimizes the impurity, right? So, however, we need to calculate for other features as well, like humidity, windy, and so on, and choose the best predictor from all possibilities. And from our train model, it looks like overcast feature was the best choice from all possibilities. As you can see, overcast was class 0. So all above 0 would go to the right and 0 into left. So once it has successfully split the training set into 2, it splits the subsets using the same logic, then the subsets again, and so on recursively. So it stops once it reaches maximum depth. And you can define this with a hyperparameter in scikit-learn, or if it cannot find a split that will reduce the impurity. So as you can see, decision trees are naturally explainable and easy to interpret. Such models are often called white box models. So in contrast, you have random forests that we are going to look at very soon, and neural networks that are generally considered as black box models. So as the name implies, CART could also be used for regression tasks. So it looks similar to the classification tree. Main difference is that instead of predicting a class in each node, it predicts a value. So the training split is to minimize the mean squared error. So the cost function that the algorithm tries to minimize is this equation. So this CART algorithm is a greedy algorithm. So it searches for an optimum split at top level, then repeats the process at each level. So it does not check if the split will lead to the lowest possible impurity several levels down. Finding optimal tree is known to be an NP-complete problem. So it's intractable even for fairly small training data. So greedy algorithms often produces a reasonably good solution, but it's not guaranteed to be optimal solution. So there are some limitations with this algorithm. So it's very sensitive to small variations in the training set. So for example, if you remove an instance and train a new decision tree, you may get a model that looks different from the previous. So for example, if you remove the index 5 and train again, we will get a completely new tree that looks different from the previous one. So random forests can limit this instability. So random forest algorithms combines many trees where each tree is trained on a random subset of the training set. So combining a group of model is referred to as an ensemble model. So in an ensemble, predictions could be combined either by majority voting or averaging the predictions. So the intuition behind ensemble learning is often described with a phenomenon called wisdom of the crowd, which means aggregated decision made by a group of individuals are often better than individual decisions. So as a random forest is an ensemble of multiple decision trees, it leverages wisdom of the crowd and is often more accurate than any individual decision trees. And this is because each individual model has its own strengths and weaknesses in predicting certain outputs. As there is only one correct prediction, but many possible wrong predictions, individual models that yield correct predictions tend to reinforce each other, while wrong predictions cancel each other out. So here's an animation which shows how it works. So you can see that it predicts as an ensemble 8 of 10 correct, while in the other cases 7 out of 10, 7 out of 10, and 6 out of 10. So for this effect to work, however, models included in the ensemble must not make the same kind of mistakes. So in other words, the models must be uncorrelated, and this is achieved through a technique called bagging. So bagging stands short for bootstrap aggregation. So in bagging, a random subset of training data is selected to train each tree. Furthermore, the model randomly restricts the variable which may be used at the splits of each tree. Hence, the trees grown are dissimilar, but they still retain certain predictive power. So in this example, we have 9 variables represented by 9 colors. So at each split, a subset of variable is randomly sampled from the original 9. Within this subset, the algorithm chooses the best variable for the split. So in this way, random forest algorithms introduces extra randomnesses when growing trees. So random forest is a flexible, easy to use machine learning algorithm that produces, even without hyperparameter tuning, a great result most of the time. So I mentioned earlier that random forests are generally considered as black box model. So if you look at a single decision tree, important features are likely to appear closer to the root of the tree, while unimportant features will often appear closer to the leaves or not at all. So it is therefore possible to get an estimate of feature importance by computing the average at which it appears across all trees in the forest. So scikit-learn computes this automatically for every feature after training, and you can get it by typing this feature importance for your trained model. So this feature importance score is from a data set called Titanic. So yeah, Titanic machine learning from disaster. So it's a very nice data set to learn about machine learning. And you can also get some ideas from other people who have done this challenge and put out notebooks for how they solved this problem and how they did this feature engineering and so on. So I will recommend you to look into this challenge if you have time. And also there are other challenges out there on Kaggle that are similar to your assignment. So you can use these notebooks to get some inspiration. So the next thing you will do now is to work with these 2 notebooks. So yeah, and I will be available on Discord from 9:15 until 11. Then it will be lab from 12 to 2 o'clock where teaching assistants will be available.